Preface. I started trying to think seriously about the evolution of the human mind when I was a graduate student in philosophy in Oxford in 1963 and knew almost nothing about either evolution or the human mind. In those days, philosophers weren't expected to know about science, and even the most illustrious philosophers of mind were largely ignorant of work in psychology, neuroanatomy, and neurophysiology. The terms cognitive science and neuroscience would not be coined for more than a decade. The fledgling enterprise dubbed artificial intelligence by John McCarthy in 1956 was attracting attention, but few philosophers had ever touched a computer, whirring mysteriously in an air-conditioned prison guarded by technicians. So it was the perfect time for an utterly untrained amateur like me to get an education in all these fields. A philosopher who asked good questions about what they were doing, instead of telling them why in principle their projects were impossible, was apparently such a refreshing novelty that a sterling cadre of pioneering researchers took me in, gave me informal tutorials, and sent me alerts about whom to take seriously and what to read, all the while being more forgiving of my naive misunderstandings than they would have been had I been one of their colleagues or graduate students. Today there are dozens, hundreds of young philosophers who do have solid interdisciplinary training in cognitive science, neuroscience, and computer science, and they are rightly held to much higher standards than I was. Some of them are my students, and even grand students, but other philosophers of my generation jumped into the deep end, often with more training than I, and have their own distinguished flocks of students making progress on the cutting edge, either as interdisciplinary philosophers or as philosophically trained scientists with labs of their own. They are professionals, and I am still an amateur, but by now a well-informed amateur who gets invited to give lectures and participate in workshops and visit labs all over the world, where I continue my education, having more fun than I ever imagined an academic life could provide. I consider this book to be, among other things, my grateful attempt to pay my tuition for all that instruction. This is what I think I've learned. A lot of it is still very conjectural, philosophical, out on a limb. I claim that it is the sketch, the backbone of the best scientific theory to date of how our minds came into existence, how our brains work all their wonders, and especially how to think about minds and brains without falling into alluring philosophical traps. That is a controversial claim, of course, and I am eagerly looking forward to engaging with the reactions of both scientists and philosophers, and the amateurs who often have the most perceptive comments of all. Daniel Dennett, North Andover, Massachusetts, March 28, 2016. Part 1. Turning Our World Upside Down. 1. Introduction. Welcome to the jungle. How come there are minds? And how is it possible for minds to ask and answer this question? The short answer is that minds evolved and created thinking tools that eventually enabled minds to know how minds evolved, and even to know how these tools enabled them to know what minds are. What thinking tools? The simplest, on which all the others depend in various ways, are spoken words, followed by reading, writing, and arithmetic, followed by navigation and map-making, apprenticeship practices, and all the concrete devices for extracting and manipulating information that we have invented: compass, telescope, microscope, camera, computer, the Internet, and so on. These in turn fill our lives with technology and science, permitting us to know many things not known by any other species. We know there are bacteria, dogs don't. Dolphins don't. Chimpanzees don't. Even bacteria don't know there are bacteria. Our minds are different. It takes thinking tools to understand what bacteria are, and we're the only species, so far, endowed with an elaborate kit of thinking tools. That's the short answer. And stripped down to the bare generalities, it shouldn't be controversial. but lurking in the details are some surprising, even shocking implications that aren't yet well understood or appreciated. There is a winding path leading through a jungle of science and philosophy, from the initial bland assumption that we people are physical objects, obeying the laws of physics, to an understanding of our conscious minds. The path is strewn with difficulties, both empirical and conceptual, and there are plenty of experts who vigorously disagree on how to handle these problems. I have been struggling through these thickets and quagmires for over 50 years, and I have found a path that takes us all the way to a satisfactory and satisfying account of how the magic of our minds is accomplished without any magic. But it is neither straight nor easy. It is not the only path on offer, but it is the best, most promising to date, as I hope to show. It does require anyone who makes the trip to abandon some precious intuitions, but I think that I have at last found ways of making the act of jettisoning these obvious truths not just bearable, but even delightful. It turns your head inside out in a way, yielding some striking new perspectives on what is going on. But you do have to let go of some ideas that are dear to many. There are distinguished thinkers who have disagreed with my proposals over the years, and I expect some will continue to find my new forays as outrageous as my earlier efforts. But now I'm beginning to find good company along my path, new support for my proposed landmarks, and new themes for motivating the various strange inversions of reasoning I will invite you to execute. Some of these will be familiar to those who have read my earlier work, but these ideas have been repaired, strengthened, and redesigned somewhat to do heavier lifting than heretofore. The new ones are just as counterintuitive at first as the old ones, and trying to appreciate them without following my convoluted path is likely to be forlorn, as I know from many years of trying and failing to persuade people piecemeal. Here is a warning list of some of the hazards to comfortable thinking you will meet on my path, and I don't expect you to get all of them on the first encounter. 1. Darwin's strange inversion of reasoning. 2. Reasons without reasoners. 3. Competence without comprehension. 4. Turing's strange inversion of reasoning. 5. Information as design worth stealing. 6. Darwinism about Darwinism. 7. Feral neurons. 8. Words striving to reproduce. 9. The evolution of culture. 10. Hume's strange inversion of reasoning. 11. Consciousness as a user illusion. 12. The age of post-intelligent design. Information as design worth stealing? Don't you know about Shannon's mathematical theory of information? Feral neurons? As contrasted with what? Domesticated neurons? Are you serious? Consciousness as an illusion? Are you kidding? If it weren't for the growing ranks of like-minded theorists, well-informed scientists and philosophers who agree with at least large portions of my view and have deeply contributed to it, I'd no doubt lose my nerve and decide that I was the one who's terminally confused. And, of course, it's possible that our bold community of enthusiasts are deluding each other. But let's find out how it goes before we chance a verdict. I know how easy, how tempting it is to ignore these strange ideas or dismiss them without a hearing when first encountered, because I have often done so myself. They remind me of those puzzles that have a retrospectively obvious solution that you initially dismiss with the snap judgment, "It can't be that," or don't even consider it as so unpromising. For someone who has often accused others of mistaking failures of imagination for insights into necessity, it is embarrassing to recognize my own lapses in this regard, but having stumbled upon or been patiently shown new ways of couching the issues, I am eager to pass on my newfound solutions to the big puzzles about the mind. All 12 of these ideas, and the background to render them palatable will be presented in roughly the order heard previously. Roughly because I have found that some of them defy straightforward defense. You can't appreciate them until you see what they can get you, but you can't use them until you appreciate them, so you have to start with partial expositions that sketch the idea and then circle back once you've seen it in action to drive home the point. The book's argument is composed of 3 strenuous exercises of imagination: turning our world upside down, following Darwin and Turing, then evolving evolution into intelligent design, and finally, turning our minds inside out. The foundation must be carefully secured in the first 5 chapters if it is to hold our imaginations in place for the second feat. The next 8 chapters delve into the empirical details of the evolution of minds and language as they appear from our inverted perspective. This allows us to frame new questions and sketch new answers, which then sets the stage for the hardest inversion of all, seeing what consciousness looks like from the new perspective. It's a challenging route, but there are stretches where I review familiar material to make sure everybody is on the same page. Those who know these topics better than I do can jump ahead if they wish, or they can use my treatments of them to gauge how much they should trust me on the topics they don't know much about. Let's get started. A bird's eye view of the journey. Life has been evolving on this planet for close to 4 billion years. The first 2 billion years, roughly, were spent optimizing the basic machinery for self-maintenance, energy acquisition, and reproduction, and the only living things were relatively simple single-celled entities, bacteria or their cousins, archaea, the prokaryotes. Then an amazing thing happened. 2 different prokaryotes, each with its own competences and habits due to its billions of years of independent evolution, collided. Collisions of this sort presumably happened countless numbers of times, but on at least one occasion, one cell engulfed the other, and instead of destroying the other and using the parts as fuel or building materials, eating it, in other words, it let it go on living, and by dumb luck found itself fitter, more competent in some ways that mattered than it had been as an unencumbered soloist. This was perhaps the first successful instance of technology transfer, a case of 2 different sets of competences honed over eons of independent R&D, research and development, being united into something bigger and better. We read almost every day of Google or Amazon or General Motors gobbling up some little startup company to get its hands on their technological innovations and savvy, advances in R&D that are easier to grow in cramped quarters than in giant corporations. But the original exploitation of this tactic gave evolution its first great boost. Random mergers don't always work out that way. In fact, they almost never work out that way, but evolution is a process that depends on amplifying things that almost never happen. For instance, mutation in DNA almost never occurs, not once in a billion copyings, but evolution depends on it. Moreover, the vast majority of mutations are either deleterious or neutral, or fortuitously good mutation almost never happens. But evolution depends on those rarest of rare events. Speciation, the process in which a new species is generated when some members get isolated from their parent population and wander away in genetic space to form a new gene pool, is an exceedingly rare event. But the millions or billions of species that have existed on this planet each got their start with an event of speciation. Every birth in every lineage is a potential initiation of a speciation event, but speciation almost never happens, not once in a million births. In the case we are considering, the rare improvement that resulted from the fortuitous collision of a bacterium and an archaeon had a life-changing sequel. Being fitter, this conjoined duo reproduced more successfully than the competition, and every time it divided in 2, the bacterial way of reproducing, both daughter cells included an offspring of the original guest. Henceforth, their fates were joined, symbiosis, in one of the most productive episodes in the history of evolution. This was endosymbiosis because one of the partners was literally inside the other, unlike the side-by-side echosymbiosis of clownfish and sea anemone or fungus and algae in lichens. Thus was born the eukaryotic cell, which, having more working parts, was more versatile than its ancestors, simple prokaryotic cells, such as bacteria. Over time, these eukaryotes grew much larger, more complex, more competent. Better, the EU in eukaryotic is like the EU in euphonious, eulogy, and eugenics. It means good. Eukaryotes were the key ingredient to make possible multicellular life forms of all varieties. To a first approximation, every living thing big enough to be visible to the naked eye is a multicellular eukaryote. We are eukaryotes, and so are sharks, birds, trees, mushrooms, insects, worms, and all the other plants and animals, all direct descendants of the original eukaryotic cell. This eukaryotic revolution paved the way for another great transition, the Cambrian explosion, more than 500 million years ago, which saw the sudden arrival of a bounty of new life forms. Then came what I call the Macready explosion, after the late great Paul Macready, visionary engineer and creator of the gossamer albatross, among other green marvels. Unlike the Cambrian diversification, which occurred over several million years about 530 million years ago, the Macready explosion occurred in only about 10,000 years, or 500 human generations. According to Macready's calculations, at the dawn of human agriculture 10,000 years ago, the worldwide human population, plus their livestock and pets, was only about 0.1% of the terrestrial vertebrate biomass. We're leaving out insects, other invertebrates, and all marine animals. Today, by his estimation, it is 98%. Most of that is cattle. His reflections on this amazing development are worth quoting. Over billions of years, on a unique sphere, chance has painted a thin covering of life, complex, improbable, wonderful, and fragile. Suddenly we humans have grown in population, technology, and intelligence to a position of terrible power. We now wield the paintbrush. There have been other relatively sudden changes on our planet, mass extinctions such as the Cretaceous-Paleogene extinction about 66 million years ago that doomed the dinosaurs. But the Macready explosion is certainly one of the fastest major biological changes ever to occur on Earth. It is still going on and picking up speed. We can save the planet or extinguish all life on the planet, something no other species can even imagine. It might seem obvious that the order of Macready's three factors, population, technology, and intelligence, should be reversed. First, our human intelligence created the technology, including agriculture, that then permitted the population boom. But, as we shall see, evolution is typically an interwoven fabric of coevolutionary loops and twists. In surprising ways, our so-called native intelligence depends on both our technology and our numbers. Our human minds are strikingly different from the minds of all other species, many times more powerful and more versatile. The long answer of how we came to have such remarkable minds is beginning to come into focus. The British biologist Darcy Thompson famously said, "Everything is the way it is because it got that way." Many of the puzzles, or mysteries or paradoxes of human consciousness evaporate once you ask how they could possibly have arisen, and actually try to answer the question. I mention that because some people marvel at the question and then answer it by saying, "It is an impenetrable mystery," or "God did it." They may in the end be right, of course, but given the fabulous bounty of thinking tools recently put at our disposal and hardly used yet, this is a strikingly premature surrender. It may not be defeatist, it may be defensive, Some people would like to persuade the curious to keep their hands off the beloved mysteries, not realizing that a mystery solved is even more ravishing than the ignorant fantasies it replaces. There are some people who have looked hard at scientific explanations and disagree. To their taste, ancient myths of fiery chariots, warring gods, worlds hatching from serpent eggs, evil spells, and enchanted gardens are more delightful and worthy of attention than any rigorous, predictive scientific story. You can't please everybody. This love of mystery is just one of the potent imagination blockers standing in our way as we attempt to answer the question of how come there are minds, and, as I already warned, our path will have to circle back several times, returning to postponed questions that couldn't be answered until we had a background that couldn't be provided until we had the tools, which couldn't be counted on until we knew where they came from. A cycle that gradually fills in the details of a sketch that won't be convincing until we can reach a vantage point from which we can look back and see how all the parts fit together. Douglas Hofstadter's book, I Am a Strange Loop, describes a mind composing itself in cycles of processing that loop around, twisting and feeding on themselves, creating exuberant reactions to reflections, to reminders, to reevaluations that generate novel structures, ideas, fantasies, theories, and, yes, thinking tools to create still more. Read it. It will take your imagination on a roller coaster ride, and you will learn a lot of surprising truths. My story in this book is of the larger strange looping process, composed of processes, that generated minds like Hofstadter's and Bach's and Darwin's out of nothing but molecules, made of atoms, Since the task is cyclical, we have to begin somewhere in the middle and go around several times. The task is made difficult by a feature it doesn't share with other scientific investigations of processes, in cosmology, geology, biology, and history, for instance. People care so deeply what the answers are that they have a very hard time making themselves actually consider the candidate answers objectively. For instance, some readers may already be silently shaking their heads over a claim I just made. Our human minds are strikingly different from the minds of all other species, many times more powerful and more versatile. Am I really that prejudiced? Am I a species chauvinist who actually thinks human minds are that much more wonderful than the minds of dolphins and elephants and crows and bonobos and the other clever species whose cognitive talents have recently been discovered and celebrated? Isn't this a bare-faced example of the fallacy of human exceptionalism? Some listeners may be ready to throw their headphones across the room, and others may just be unsettled by my politically incorrect lapse. It's amusing, to me at least, that human exceptionalism provokes equal outrage in opposite directions. Some scientists and many animal lovers deplore it as an intellectual sin of the worst kind, scientifically ill-informed, an ignoble vestige of the bad old days when people routinely thought that all dumb animals were put on this planet for our use and amusement. Our brains are made of the same neurons as bird brains, they note, and some animal brains are just as large, and just as smart in their own species-specific ways, as ours. The more you study the actual circumstances and behaviors of animals in the wild, the more you appreciate their brilliance. Other thinkers, particularly in the arts and humanities and social sciences, consider the denial of human exceptionalism to be myopic, doctrinaire, scientism at its worst. Of course our minds are orders of magnitude more powerful than the cleverest animal mind. No animal creates art, writes poetry, devises scientific theories, builds spaceships, navigates the oceans, or even tames fire. This provokes the retort, what about the elegantly decorated bowers built by bowerbirds, the political subtlety of chimpanzees, the navigational prowess of whales and elephants and migrating birds, the virtuoso song of the nightingale, the language of the vervet monkeys, and even the honeybees? which invites the response that these animal marvels are paltry accomplishments when compared with the genius of human artists, engineers, and scientists. Some years ago, I coined the terms romantic and killjoy to refer to the sides of this intense duel over animal minds, and one of my favorite memories of this bipolar reaction to claims about animal intelligence occurred at an international scientific workshop on animal intelligence, where one distinguished researcher managed to play both romantic and killjoy roles with equal passion. "Ha! You think insects are so stupid? I'll show you how smart they are. Consider this result." Followed later on the same day by, "So you think bees are so clever? Let me show you how stupid they really are. They're mindless little robots." Peace. We will see that both sides are right about some things and wrong about others. We're not the godlike geniuses we sometimes think we are, but animals are not so smart either, and yet both humans and other animals are admirably equipped to deal brilliantly with many of the challenges thrown at them by a difficult, if not always cruel, world. And our human minds are uniquely powerful in ways that we can begin to understand once we see how they got that way. Why do we care so much? That is one of the many hanging questions that needs an answer, but not right now, except in briefest outline. While the processes that gave rise to this caring go back thousands of years, and in some regards millions or even billions of years, they first became a topic, an object to think about and care about, at the birth of modern science in the 17th century. So that is where I will break into the ring and start this version of the story. The Cartesian Wound. Sì, abbiamo un'anima, ma è fatta di tanti piccoli robot. Yes, we have a soul, but it's made of lots of tiny robots. Headline for an interview with me by Giulio Girello in Corriere della Sera, Milan, 1997. René Descartes, the 17th century French scientist and philosopher, was very impressed with his own mind, for good reason. He called it his res cogitans, or thinking thing, and it struck him on reflection as a thing of miraculous competence. If anybody had the right to be in awe of his own mind, Descartes did. He was undoubtedly one of the greatest scientists of all time, with major work in mathematics, optics, physics, and physiology, and the inventor of one of the most valuable thinking tools of all time, the system of Cartesian coordinates that enables us to translate between algebra and geometry, paving the way for calculus and letting us plot almost anything we want to investigate, from aardvark growth to zinc futures. Descartes propounded the original TOE, theory of everything, a prototypical grand unified theory which he published under the immodest title Le Monde, the World. It purported to explain everything from the orbits of the planets and the nature of light to the tides, from volcanoes to magnets, why water forms into spherical drops, how fire is struck from flint, and much, much more. His theory was almost all dead wrong, but it held together surprisingly well, and is strangely plausible even in today's hindsight. It took Sir Isaac Newton to come up with a better physics in his famous Principia, an explicit refutation of Descartes' theory. Descartes didn't think it was just his mind that was wonderful. He thought that all normal human minds were wonderful, capable of feats that no mere animal could match. Feats that were beyond the reach of any imaginable mechanism, however elaborate and complicated. So he concluded that minds like his and yours were not material entities like lungs or brains, but made of some second kind of stuff that didn't have to obey the laws of physics, articulating the view known as dualism, and often Cartesian dualism. This idea that mind isn't matter and matter can't be mind was not invented by Descartes. It had seemed obvious to reflective people for thousands of years that our minds are not like the furniture of the external world. The doctrine that each of us has an immaterial and immortal soul that resides in and controls the material body long past for shared knowledge, thanks to the instruction of the Church. But it was Descartes who distilled this default assumption into a positive theory. The immaterial mind, the conscious thinking thing that we know intimately through introspection, is somehow in communication with the material brain, which provides all the input, but none of the understanding or experience. The problem with dualism ever since Descartes is that nobody has ever been able to offer a convincing account of how these postulated interactive transactions between mind and body could occur without violating the laws of physics. The candidates on display today offer us a choice between a revolution in science so radical that it can't be described, which is convenient since critics are standing by ready to pounce, or a declaration that some things are just mysteries beyond human understanding, which is also convenient if you don't have any ideas and want to exit swiftly. But even if, as I noted years ago, dualism tends to be regarded as a cliff over which you push your opponents, those left on the plateau have a lot of unfinished business constructing a theory that is not dualism in disguise. The mysterious linkage between mind and matter has been a battleground of scientists and philosophers since the 17th century. Francis Crick, the recently deceased co-discoverer of the structure of DNA, was another of history's greatest scientists, and his last major piece of writing was The Astonishing Hypothesis, The Scientific Search for the Soul, 1994, in which he argued that dualism is false. The mind just is the brain, a material organ with no mysterious extra properties not found in other living organisms. He was by no means the first to put forward this denial of dualism. It has been the prevailing, but not unanimous, opinion of both scientists and philosophers for the better part of a century. In fact, many of us in the field objected to his title. There was nothing astonishing about this hypothesis. It had been our working assumption for decades. Its denial would be astonishing, like being told that gold was not composed of atoms or that the law of gravity didn't hold on Mars. Why should anyone expect that consciousness would bifurcate the universe dramatically, when even life and reproduction could be accounted for in physico-chemical terms? But Crick wasn't writing his book for scientists and philosophers, and he knew that among lay people the appeal of dualism was still quite overpowering. It seemed not only obvious to them that their private thoughts and experiences were somehow conducted in some medium in addition to the neuronal spike trains scientists had found buzzing around in their brains, but the prospect of denying dualism threatened horrible consequences as well. If we are just machines, what happens to free will and responsibility? How could our lives have meaning at all if we are just huge collections of proteins and other molecules churning away according to the laws of chemistry and physics? If moral precepts were nothing but extrusions generated by the hordes of microbiological nanomachines between our ears, how could they make a difference worth honoring? Crick did his best to make the astonishing hypothesis not just comprehensible, but also palatable to the lay public. Despite his clear and energetic writing and unparalleled gravitas, he didn't make much progress. This was largely, I think, because in spite of his book's alarm bell of a title, he underestimated the emotional turmoil this idea provokes. Crick was an excellent explainer of science to non-scientists, but the pedagogical problems in this arena are not the usual ones of attracting and holding the attention of semi-bewildered and intimidated laypeople, and getting them to work through a smattering of math. When the topic of consciousness arises, the difficult task is to keep a lid on the anxieties and suspicions that seduce people, including many scientists, into distorting what we know and aiming preemptive strikes at dangerous ideas they dimly see looming. Moreover, on this topic, everybody's an expert. People are calmly prepared to be instructed about the chemical properties of calcium or the microbiological details of cancer, but they think they have a particular personal authority about the nature of their own conscious experiences that can trump any hypothesis they find unacceptable. Crick is not alone. Many others have tried their hand at knitting up what one of the best of them, Terence Deacon, has called the Cartesian wound that severed mind from body at the birth of modern science. Their efforts are often fascinating, informative, and persuasive, but no one has yet managed to be entirely convincing. I have devoted half a century, my entire academic life, to the project in a dozen books and hundreds of articles tackling various pieces of the puzzle, without managing to move all that many readers from wary agnosticism to calm conviction. Undaunted, I am trying once again and going for the whole story this time. Why do I think it is worth trying? Because first, I think we have made tremendous scientific progress in the last 20 years. Many of the impressionistic hunches of yore can now be replaced with well-researched details. I plan to rely heavily on the bounty of experimental and theoretical work that others have recently provided. And second, I think I now have a better sense of the various undercurrents of resistance that shackle our imaginations, and I plan to expose and disarm them as we go, so that, for the first time, the doubters can take seriously the prospect of a scientific, materialist theory of their own minds. Cartesian gravity. Over the years, trudging back and forth over the battleground, participating in many skirmishes, I've gradually come to be able to see that there are powerful forces at work, distorting imagination, my own imagination included, pulling us first one way and then another. If you learn to see these forces too, you will find that suddenly things begin falling into place in a new way. You can identify the forces tugging at your thinking, and then set up alarms to alert you and buffers to protect you, so that you can resist them effectively while simultaneously exploiting them, because they are not just distorting, they can also be imagination-enhancing, launching your thinking into new orbits. One cold, starry night over 30 years ago, I stood with some of my Tufts students looking up at the sky, while my friend, the philosopher of science, Paul Churchland, instructed us on how to see the plane of the ecliptic. That is, to look at the other visible planets in the sky and picture them, and ourselves, as wheeling around the sun all on the same invisible plane. It helps to tip your head just so, and remind yourself of where the sun must be, way back behind you. Suddenly, the orientation clicks into place and shazam, you see it. Of course, we all knew for years that this was the situation of our planet in the solar system, but until Paul made us see it, it was a rather inert piece of knowledge. Inspired by his example, I am going to present some eye-opening, actually mind-opening, experiences that I hope will move your mind into some new and delightful places. The original distorting force, which I will call Cartesian gravity, actually gives birth to several other forces, to which I will expose you again and again in different guises, until you can see them clearly too. Their most readily visible manifestations are already familiar to most everyone. Too familiar, in fact, since we tend to think we have already taken their measure. We underestimate them. We must look behind them and beyond them to see the way they tend to sculpt our thinking. Let's begin by looking back at Crick's astonishing hypothesis. Those of us who insist that we don't find it at all astonishing fuel our confidence by reminding ourselves of the majestic array of well-solved puzzles, well-sleuthed discoveries, well-confirmed theories of modern materialistic science that we all take for granted these days. When you think about it, it is just amazing how much we human beings have figured out in the few centuries since Descartes. We know how atoms are structured, how chemical elements interact, how plants and animals propagate, how microscopic pathogens thrive and spread, how continents drift, how hurricanes are born, and much, much more. We know our brains are made of the same ingredients as all the other things we've explained, and we know that we belong to an evolved lineage that can be traced back to the dawn of life. If we can explain self-repair in bacteria and respiration in tadpoles and digestion in elephants, why shouldn't conscious thinking in H. sapiens eventually divulge its secret workings to the same ever-improving, self-enhancing scientific juggernaut? That's a rhetorical question, and trying to answer rhetorical questions instead of being cowed by them is a good habit to cultivate. So might consciousness be more challenging than self-repair or respiration or digestion? And if so, why? Perhaps because it seems so different, so private, so intimately available to each of us in a way unlike any other phenomenon in our living bodies. It is not all that hard these days to imagine how respiration works, even if you're ignorant of the details. You breathe in the air, which we know is a combination of different gases, and we breathe out what we can't use, carbon dioxide, as most people know. One way or another, the lungs must filter out and grab what is needed, oxygen, and exude the waste product, carbon dioxide. Not hard to grasp in outline. The phenomenon of smelling a cookie and suddenly remembering an event in your childhood seems, in contrast, not at all mechanical. Make me a nostalgia machine. What? What could the parts possibly do? Even the most doctrinaire materialists will admit that they have only foggy and programmatic ideas about how brain activities might amount to nostalgia or wistfulness or prurient curiosity, for example. Not so much an astonishing hypothesis, many might admit, as a dumbfounding hypothesis, a hypothesis about which one can only wave one's hands and hope. Still, it's a comfortable position to maintain, and it's tempting to diagnose those who disagree, the self-appointed defenders of consciousness from science, as suffering from one or another ignominious failing. Narcissism. I refuse to have my glorious mind captured in the snares of science. Fear. If my mind is just my brain, I won't be in charge. Life will have no meaning. Or disdain. These simple-minded scientistic reductionists, they have no idea how far short they fall in their puny attempts to appreciate the world of meaning. These diagnoses are often warranted. There is no shortage of pathetic bleats issuing from the mouths of the defenders, but the concerns that motivate them are not idle fantasies. Those who find Crick's hypothesis not just astonishing but also deeply repugnant are onto something important. And there is also no shortage of anti-dualist philosophers and scientists who are not yet comfortable with materialism and are casting about for something in between, something that can actually make some progress on the science of consciousness without falling into either. The trouble is that they tend to misdescribe it, inflating it into something deep and metaphysical. What they are feeling is a way of thinking, an overlearned habit, so well entrenched in our psychology that denying it or abandoning it is literally unthinkable. One sign of this is that the confident scientific attitude expressed by the other side begins to tremble the closer the scientists get to a certain set of issues dealing with consciousness, and they soon find themselves, in spite of themselves, adopting the shunned perspective of the defenders. I am going to describe this dynamic process metaphorically at the outset to provide a simple framework for building a less metaphorical, more explicit and factual understanding of what is happening. Suppose the would-be mind explainer starts with her own mind. She stands at home on planet Descartes, meditating on the task ahead and looking at the external universe from the first-person point of view. From this vantage point, she relies on all the familiar furniture of her mind to keep her bearings, and Cartesian gravity is the force that locks her into this egocentric point of view from the inside. Her soliloquy might be, echoing Descartes, "Here I am, a conscious thinking thing intimately acquainted with the ideas in my own mind, which I know better than anybody else just because they're mine. She cannot help but be a defender of her own home. Meanwhile, from far away comes the scientific explorer of consciousness, approaching planet Descartes confidently, armed with instruments, maps, models, and theories, and starts moving in for the triumphant conquest. The closer she gets, however, the more uncomfortable she finds herself. She is being dragged into an orientation she knows she must avoid, but the force is too strong. As she lands on planet Descartes, she finds herself flipped suddenly into first-person orientation, feet on the ground, but now somehow unable to reach or use the tools she brought along to finish the job. Cartesian gravity is all but irresistible when you get that close to the surface of planet Descartes. How did she get there? And what happened in that confusing last-minute inversion? Strange inversions will be a major theme in this book. There seem to be two competing orientations, the first-person point of view of the defenders and the third-person point of view of the scientists, much like the two ways of seeing the philosopher's favorite illusions, the duck-rabbit and the Necker cube. You can't adopt both orientations at once. The problem posed by Cartesian gravity is sometimes called the explanatory gap, but the discussions under that name strike me as largely fruitless because the participants tend to see it as a chasm, not a glitch in their imaginations. They may have discovered the gap, but they don't see it for what it actually is because they haven't asked how it got that way. By reconceiving of the gap as a dynamic imagination distorter that has arisen for good reasons, we can learn how to traverse it safely or, what may amount to the same thing, make it vanish. Cartesian gravity, unlike the gravity of physics, does not act on things in proportion to their mass and proximity to other massy items. It acts on ideas or representations of things in proportion to their proximity in content to other ideas that play privileged roles in the maintenance of a living thing. What this means will gradually become clear, I hope, and then we can set this metaphorical way of speaking aside, as a ladder we have climbed and no longer need to rely on. The idea of Cartesian gravity, as so far presented, is just a metaphor, but the phenomenon I am calling by this metaphorical name is perfectly real, a disruptive force that bedevils and sometimes aids our imaginations, and unlike the gravity of physics, it is itself an evolved phenomenon. In order to understand it, we need to ask how and why it arose on planet Earth. It will take several passes over the same history, with different details highlighted each time, to answer this question. We tend to underestimate the strength of the forces that distort our imaginations, especially when confronted by irreconcilable insights that are undeniable. It is not that we can't deny them, it is that we won't deny them, won't even try to deny them. Practicing on the forces that are easy to identify, species chauvinism, human exceptionalism, sexism, prepares us to recognize more subtle forces at work. In the next chapter, I turn briefly to the very beginning of life on the planet and give a preliminary outline of the story to come, with scant detail, and also tackle one of the first objections that, I predict, will occur to the reader while encountering that outline. I cast evolutionary processes as design processes, processes of research and development, or R&D, and this adaptationist or reverse engineering perspective has long lived under an undeserved cloud of suspicion. Contrary to widespread belief, as we shall see, adaptationism is alive and well in evolutionary biology.